Okay guys, last example for this lesson. We're going to be sketching log graphs with transformations. Now we're going to do a little checklist whenever you guys are drawing log graphs. First thing, you need to check for your asymptote. Okay? Second thing, you need to check if it is shifted to the left or to the right. Okay? Next, you need to check if it is shifted up or down. Alright, now once you have all of those, you also need to have a point to be shown on your graph. Okay, now there is two examples we're going to go through today. The first example is this. We have y equals to log base 2, x minus 3 plus 2. So, first of all, we want to check for our graphs. We're going to draw up your x and y axes. Okay, make sure you guys have arrows on both ends. X, y, and 0. Next, we're going to look for our asymptote. So to look for the asymptote, you look at the brackets, technically. So if we have a look here, okay, x minus 3, if you make that equal to 0 and solve for x, x is positive. That means it's shifted to the right. So how I remember it is that these brackets kind of look like crabs. And crabs basically move to the left or the right. And this crab here that we have is moving to the right to number 3. So your asymptote is going to be at x equals to 3. Okay, now just remember your log graph is usually one number to your right. Yeah, now next one, your log graph is shifted up plus 2. Yeah, so we want to find our x-intercept technically. So to find your x-intercept, you make y equals to 0. When y equals to 0, we're going to substitute it in log base 2 x minus 3 plus 2. Okay, let's solve for it. We're going to bring positive 2 over to this side. We have minus 2 equals to log base 2 x minus 3. Remember, if this format is too confusing for you, you can swap it around. Alright, equals to minus 2. You want to get rid of the log, so we're going to shove up the number 2, so bump it up. The log disappears. You have left x minus 3 equals to 2 to the power of minus 2. You can put that into your calculator, 2 to the power of minus 2, which is 1 over 4. We have x minus 3 equals to 1 over 4. Solve for x, bring that across. Your x is 1 over 4 plus 3, which is 3.25. So we know here your x-intercept is going to be 3.25. Draw your logarithmic graph, which is roughly like this, but we need to have a point shown in the graph. So when we substitute any point you like, I'm going to choose the next number, a whole number, number 4. Okay, so when x equals to 4, we're going to substitute it right back into the equation. So y equals to log base 2, 4 minus 3 plus 2. Y equals to log base 2 to 1 plus 2. Okay, and if you put it into your calculator, log base 2 1 is technically 0. So 0 plus 2 is 2. So your y value is 2. So that point there is 4, 2. If you don't know how to put it into the calculator yet, you can leave it as log base 2 plus 1, log base 2, 1 plus 2. Okay, so, or alternately, you can write it like this. Log base 2, 1 plus 2, comma, 2. And that's another way, as long as you have your point there. Alright? So next type of log we have is this one. So we're going to do the same thing. We're going to draw our axes. We have your x, y, 0. We're going to look at where your logarithmic graph is being shifted. So looking at this, remember it's a crab. You're going to make it equal to 0. So x plus 2 equals 0. X is minus 2. So we know your graph is being shifted this time to the left. And that's your asymptote. Okay. Now, we want to find your x-intercept. So we're going to write x-intercept. You make y equals to 0. Same type of gist. So 0 is log base 5. X plus 2 minus 1. We have 1 equals to log base 5. X plus 2. Remember, if this format is confusing, you guys can swap it around. So log base 5 x plus 2 equals 1. To get rid of the log, we're gonna bump up the 5 to the other side. So log disappears. X plus 2 equals 5 to the power of 1. We know 5 to the power of 1 is 5. Solve for x, bring the plus 2 across. X equals to 5 minus 2, which is 3. So your x-intercept, we know, is at 3. Okay, so if we draw this roughly, you guys can kind of see that this log graph has a y-intercept as well. So to find your y-intercept, you make x equals to 0. So y equals to log 5, 0 plus 2 minus 1. So log base 5, 2 minus 1. Okay, we haven't learnt how to put this whole number here as a exact value yet. But if you really do want to know, this is the same as log 2 over log 5, but we will talk more about this for next lesson. Okay, so put it into your calculator if you guys like. So y equals to log 2 over log 5 minus 1. How I usually remember it is that if 2 is the bigger guy, it stays on top. The 5 is technically already at the base, so that is at the base. Into your calculator, log 2 over log 5 minus 1, and you should end up with a number of minus 0.56932344419. Okay, if you don't want to write down the whole number, you can just write the equation or the algebraic expression log base 5 2 minus 1, okay, as your y-intercept. Just remember, I made a mistake. Your x value goes first, so it's 0, and then your y value. Or alternatively, you can write it as this, as a coordinate. Okay, and that's all you need to do.